Alright guys, good afternoon. We are going to be going over Chapter 4 again for Exam 2 review. This one's going to be our number 4.28. This one will be in your book. So this is going to be another frame. We have a pin at C and a roller at A at some angle alpha. We have a 300 Newton force in between the center of C and B, and another 300 Newton force at the end of B, all going to the right. The question asks us to find the reactions at A and C when alpha is at 0 degrees and alpha is at 30 degrees. Being that alpha is going to be at 0 degrees, that's going to be a pretty simple problem. So I'm not going to do it. Instead, I'm going to do the harder one for y'all. So I'm going to do it though alpha is at 30 degrees. So to start it off, we need to draw our free body diagram. So we have a pin at C, so we have a CY and a CX, and we have our reaction at A. Now it's going to be at some angle alpha. If you look right here, they have it given to us at alpha from the horizontal. But when it's at an angle on a roller, it's going to be a reaction force that's perpendicular to the plane that it's going to be sitting on. So that is why we have a force right here perpendicular to that plane. So law of interior angles, if this is alpha here at the horizontal, this one right here from the vertical will also be alpha. Now these points that I have drawn out right here, this is going to be to help demonstrate on how we're going to do the moment equation here in just a minute. So to begin this problem, all we need to do is to start taking our sum of forces. So sum of forces in the x equal to 0. Always state which way you're going to say is positive. We have a positive Cx. I'm going to combine the 300 Newton forces to be a total of 600 Newton force. And we have our force A going to be at the x direction, so it's going to be at sine alpha is equal to 0. Now take our sum of forces in the y equal to 0. We're going to state that positive up. We have a positive cy and a positive fa cosine alpha, all equal to 0. Now we have two unknowns and two equations. We cannot solve for anything right now, so we need to take a moment. So we're going to take a moment, take a moment about the point that's going to take away the most out of amount of unknowns. So we're going to take it about c, all equal to 0. I'm going to say that counterclockwise is positive. So we're going to have a 300 Newton force going in a clockwise rotation. And that's going to be at, I'm going to go ahead and convert it to 2 meters, 0.2 meters. We're going to have another 300 Newton force at 0.4 meters. And now we're going to have to worry about F of A. Now this is where this is going to come in. So at F of A, if we're looking at a force going up in the y direction, our perpendicular distance is going to be in the x direction. So it's going to be at this 0.8 meters right here. We're going to have a negative force in the a direction because it's going to be a clockwise rotation. Now this is going to also be with sine alpha times 0.8 meters. Now we're going to have to worry about the x, or the force of A, in the x direction or y direction. So we have a force going in the x direction. Our perpendicular distance is going to be in the y direction. That's going to be causing a counterclockwise rotation. So it's going to be a positive f of A cosine of alpha times that perpendicular distance, which is going to be 0.4 meters, all equal to 0. Simplifying it down and solving for f of A, we can pull f of A out as our common factor. It's all going to be equal to, go ahead and simplify those 300 newtons times the 0.2 meters and the 300 meters times newtons times 0.4 meters. That's going to be a negative 180, moving it over to the side that we need it on, Newton meters, all over negative sine 30 degrees times 0.8 meters plus cosine 30 degrees times 0.4 meters. We get an f of A to be, scroll down to where I actually have my answer, because I have this all written out already ahead of time. We get 365.24 newtons at force A. Now we have A, we can solve for Cx and Cy. Solving for CX, all you do is just take out your common factors, move them all to the right side, get CX by itself. Solving for CX, we get negative 782.62 newtons. Note that it says it's at a negative, so we assumed our direction wrong, but that's perfectly fine. The math comes out to what we need it. We find CY. Solving for CY, we get CY to be a negative 316 newtons. Also, we assume that that direction was wrong as well, but that's okay, as long as we got our values. So chapter 4, as long as it's a 2D frame, they'll be pretty quick, pretty straight, easy. My best recommendation to you is if you have a really good grip on chapter 4 and a decent grip of chapter 5, but not in chapter 6 for the exam 2, go ahead and start the exam on chapter 6, because that's going to take up most of your time. Also, as a side note, do be sure to write your name on every single page that you do for the exam, including the cover page that he gives you that has the problems written on it. Write your name on every single page, even if you have to, put a page number on every single page. That will help you keep your track, and that helps Dr. Jackson know where your papers are at, so that way he doesn't get lost and confused, and possibly gives you a bad grade because he couldn't find your name on your papers. And also, if he gives you a question that's a freebie question, just a free give me 4 to 6 points, take advantage of it. Go ahead and do those free points, and you will be thanking yourself later. Other than that, that is it for chapter 4. We will be moving on to chapter 5 in the next video, so please stay tuned. Thanks.